I'm Vinitha Gadiraju. I'm a PhD student at the University of Colorado Boulder, and today I'll be presenting our paper, It is Fascinating to Make These Bees Fly, Understanding Visually Impaired People's Motivations and Needs for Drone Piloting. I'm presenting on behalf of myself and my co-authors, Jérémie Garcia, Shaun, Kane, and Anke. So drones have become popular tools for personal and commercial applications, ranging from entertainment to delivery, search and rescue, and even crisis support. However, operating or piloting drones remains largely inaccessible to people with disabilities, including vision impairment. This inaccessibility stems from the dependence on visual information to control the drone, combined with the physical and cognitive skills needed to pilot. Researchers have started to investigate making drone piloting accessible to people with cognitive and motor impairments through tangible interaction, such as block-based controls. So for example, in the image on screen, we see a participant using arrow-shaped blocks to control the direction that the drone is flying in. For blind or visually impaired people, drones have been explored as an assistive technology to support various activities, like guidance for pedestrians and runners. Researchers have also used drones for exploring hand-object localization tasks in new environments and to teach orientation and mobility, which is a core component of education for visually impaired people. However, little qualitative work has centered blind or visually impaired people as pilots of the drones. Additionally, few have looked at if and why drone piloting is of actual interest to people with vision impairment. To address this gap, our work aims to understand if visually impaired people are motivated to fly drones, and if so, what contexts, modalities, and forms of feedback can enable accessible piloting. To do this, we surveyed 59 blind or visually impaired adults and interviewed 13 of these respondents in the United States, France, and Australia about their interest and experiences with drone piloting. We first focused on determining if blind or visually impaired people had an existing interest in drones, and then further characterized how they envisioned flying drones. We asked participants questions about their current hobbies and recreational interests and how drones could fit in with these activities. In our survey, we saw that our respondents were indeed interested in flying drones, with 54% of respondents marking an interest of 5 on a 5-point Likert scale. From our interviews, we were also able to broadly define 5 personas that described why our participants were interested in piloting and using drones. While each participant was at least one of these personas, we want to note that there was an overlap in interests and some participants fell into more than one category. So now we can delve into the personas, and the first one is the Navigator. This is someone who lives in the center of a big city and takes public transportation to work and around the city. They use navigation applications like Aira and Microsoft's Soundscape, but they want more detailed information about obstacles in their path. Participant 1 said, "Landscape changes so frequently. People park all kinds of junk on the road. Give me all the potential pitfalls that I should avoid." The next persona is the Environment Explorer. This person loves to travel, particularly to islands that they can whale watch in. They have never used drones, but are curious to know if drones can give them information about the new places that they discover. Participant 5 says, "Drones get into places that a human could never get to. Things that spring to mind are like David Attenborough, but with a drone." The third persona is the Family Flyer. This person lives in the suburbs and often goes to the park with their sighted child. As a family, they like to ski, hike, and bike on the weekends. They are curious about how to use drones to support their family activities. Participant 2 says, "We want to be a more active family once Corona is over. We would love to get involved in hiking, skiing, cycling, stuff like that." Next is the technology fan. This person has worked in the technology field professionally, and they often tinker with tools in their free time, like Raspberry Pi, to make different technology accessible. They're willing to pay well to try new technology, particularly if it has features that are accessible to visually impaired people. As P13 succinctly says, "It revolts me to take price as a reason for not trying new technology." Finally, we have the aviation enthusiast. This is someone who's interested in all facets of aviation. They used to build model planes and cars as a child, and they enjoy playing with remote-controlled cars and have some experience using joysticks and controllers. Participant 10 says, "Nowadays man thinks it's normal to take off and land, but it's still a miracle. It's fabulous. Physics and science explain it, but we are still amazed. So now that we've seen the different motivations a drone user can have, we start looking at features that can support these motivations and create accessible interactions. We asked participants about how drone features can support these specific areas they're interested in. We also asked about different methods for piloting drones and what feedback they want to receive while piloting. We found that certain personas wanted certain features in common. For example, the Navigator and the Environment Explorer are both looking for information about their surroundings in public places. Therefore, they want voice commands so they can keep their hands free for recreational use or to use their cane while navigating. They also want more discrete forms of control and feedback, such as controlling and receiving information about the drone through their phone. Similarly, these users may need smaller, discrete drones that do not draw too much attention. Finally, these personas already use applications such as Ira and Microsoft Soundscape, so they express that they want drones to have the ability to work with these applications rather than replace them. As far as feedback, we primarily focused our interview on how audio and haptics can provide participants with information while piloting. We split audio into two categories: spoken information and sounds. Participants felt that spoken information, similar to voiceover, should be reserved for safety threats to the drones, such as crash warnings, and crucial environmental information like obstacle detection. Supplemental beeps, tones, and ambient sounds could better describe where the drone moves, characterize the 3D space, and give perceptual cues about the user's environment. While audio feedback is ideal for free flying and environmental information, participants explained that tactile feedback is helpful for object detection and proximity, spatial awareness and distance perception, and directional information. Participants suggested receiving haptic feedback on their wrists and hands through bracelets, armbands, watches, and gloves, as these tended to be sensitive parts of the body and had clear distinction between right and left directions. However, two participants advocated for just receiving haptic feedback on their phone so they would not be encumbered by carrying additional wearables whenever they wanted to pilot. The personas we created present different contexts that visually impaired people want to fly in. In future work, we are interested in testing different input configurations like voice commands, controllers, and smartphones with feedback combinations like vibrotactile haptics and audio. Thank you for taking the time to listen to our work. I would like to thank my co-authors, Jérémie Garcia, Shaun, Kane, and Anke, our colleagues at the Interactive Informatics team and the Superhuman Computing Lab for their support of this work, and our participants for collaborating with us on this project. Thank you.